Hello everyone, my name is Anobil Hamza and today I will be doing my lab report presentation 2 which is on chapter 3 Bernoulli's equation. So for introduction, based on Bernoulli's equation, as you can see here, P1 plus 1 over 2 rho V1 squared plus rho GH1 equal a constant which is equal to the second part of the portion. So for example, if we compare this, point 1 it will be equal to point 2. So for a fluid system, water in a pipe in this case, for an increase of flow velocity, the pressure produced by fluid is decreased. So this is what stated by Bernoulli. However, the total magnitude of static pressure and kinetic pressure is constant. So we can say that this is equal to a constant. So it's important to note that the assumptions are incompressible fluid, steady flow, and neglect viscosity. Conservation of mass can also be applied for calculation, which is flow rate equal area 1 times velocity 1 equal A2 B2. So objective of this experiment is 1. To prove relationship stated in Bernoulli's equation, to test for conservation of mass, and 3. To check for relationship between velocity and static pressure. This is the experiment setup. So as you can see, this is the water supply. This is the static pressure tapping, which is the main thing we will be measuring. This is the collection tank and this is converging divergent duct. So basically this is where it will flow. This is a smaller diameter, this is equal in diameter, around equal diameter here. So procedure is first set up the experiment as shown in the diagram. Run the pump and make sure the test section is filled with water. This is the test section. Bubbles in the manometer. Adjust swivel tube at the outlet tank to obtain head of 100 mm. Height of water is marked and measured in each manometer tubes. Record the data. Measure the time taken to fill the measuring tank from 0 to 10 liters. So this is the result we get after doing the procedure. So this is distance from inlet, as you can see, and this is the velocity and everything else you can see here. If you can see here, the highest velocity here is 2.275, which coincidentally have the smallest flow area, which you can see is at here. So this is what the data is telling us. So to see this clearly, we plot it in graph to check for the relationship better based on the raw data here. So for the discussion, as you can see here, as the static head decrease. So before going to that, so I want to say that this is the head in meter. Plot again distance in inlet. So what it is saying is head is plot again the distance from the inlet. So this is 1, 2 and so forth. So as you can see here is this for the blue portion, it is blue. This is the static head measurement. The green one is the dynamic head, and this is the total head. So as you can see, as the static head decrease, the velocity coincidentally peak at that points, which proves the relationship that Bernoulli stated, which is as velocity increase, the static pressure decrease, the pressure of the fluid. So as you can see, the relationship here overlap. As the dynamic pressure increase, the static pressure will decrease, and vice versa. And also, if you can see here is for the total head, if this is an ideal fluid, if this is a perfect environment with no error at all, this is expected to be a straight line, a constant. But here we said that here we can see that the total head decrease and basically is fluctuate, and generally it is in the decreasing trend. So what we can conclude is error can be attributed to friction. So basically as the water flow through the pipe, there is a friction that causes an energy loss that cannot be obtained back. It is lost forever. So this is what we see here, and the energy loss resulted in the pressure drop. And as you can see, this shows that the relationship of Bernoulli's equation is true, which is one of our objectives. Also, the error in this total head can also attributed to human error, which is calculation error. Basically, if we make an error during measuring the head of static head, everything in calculation, which can lead to this error. But most likely it is caused by friction. So as you can see here, this is the total head of 1, this is 11. If this is an ideal situation, it will be the same line. So based on everything, that's all for today. Thank you.